So look at this question 12. Uh, so we go through the whole questions. For function ex and function gx is quadratic. So state the domain and range for this both function. So this we can use whatever we already learned here. Domain. Which one is special case? Domain of function ex, not special case. So domain of gx quadratic also not special case. So range of the function range. So this is exponential function. When you close this part, you can see value up there is 0. So it will be 0 to infinity. For the range of the gx, so it's not special case, right? Yes, it is special case quadratic. So when you close this part, it is also a value 0 out there, but quadratic you need to include that point. That will be the minimum point. Okay. So this is your one mark about domain and range for fx, another mark domain and range for gx. And then proceed for your composite function, g, f, x. So substitute your fx. When you show, means you have to do until that answer. It's not using the answer and continue answer. Alright, it's not starting with this statement. So that means do this part until getting this answer. Substitute your fx. And then substitute this e negative x into x part here. Shown also. So this is our composite concept and answer. Then we go for question B. They give us a piecewise function here. So you can see our piecewise function. Find the f inverse. So you have to look at your graph and see, is it your piecewise function, is it one-to-one function. If it is one-to-one function, means whole part of the graph can be inverse. But if it's not one-to-one function, then you have to figure out which one you have to inverse. So you can see when you draw this graph, so we're just sketching. Okay, we have a graph here. When you have x less than 0, means from this 0 to the left hand side, we are drawing exponential function. But for x more than 0, this part we were going to have linear function. So this linear function is a straight line intersect as 1. So this is our linear function intersect as 1. For this exponential function, e to the power of negative 2x, and then range is start from 0. So asymptote at 0, as you know, asymptote at 0. And then negative 2x means you're going to shoot up to left hand side. Okay, so you will shoot up to left hand side. So, but you're only drawing one part only, left hand side part only. So when x equals to 0, your e intersect is 1 also. So you will start joining from here. So you'll notice that your graph here is not one-to-one function. When you have the whole part of this fx, it is not one-to-one function. When you put your horizontal line test, it will intersect two parts. So therefore, when you want to find the h inverse, means we are going to find h inverse only axis we pick a domain that will make this piecewise function inverse. So either we can choose left hand side or either we can choose right hand side graph, either one graph to be chosen in order to make this function inverse. Alright, so we can choose the left hand side. So means we are going to take this part for inverse only. So this part not involved. Selected one part of the questions and then we inverse it. So we start our inverse. H inverse x equals to y. Then hy equals to x. E negative 2y equals to x. So we're going to get our y. Okay, move your e will be ln x. Then find your y here, 1 over 2x. That will be our H inverse. Oh, so this one got negative. Okay, so this is inverse concept. How you simplify to get your ln and find out your inverse part. Find out your inverse part first. Determine you're going to do it left hand side or you're going to do it right hand side. Then that will be our answer. Okay or not? Okay, so we go for the inverse part because we're taking the left hand side, so I will draw the graph for left hand side and inverse it. Okay, so set up your inverse graph where your y-axis, x-axis correctly. And don't forget our reflection line here, y equals to x. So for this exponential originally is left hand side part and then asymptote at 0 here. So it's supposedly it's like that. Your graph will be starting from here, but this part is not taking, right? So we no need to draw. We only show the part they want. So you should up at here, 1. Therefore, when you inverse, when you flip the graph, when you inverse, you reflect the graph, you will get your hx and your h inverse at here. So this is the intercept you have to write out. 0 origin and label everything. Okay, so this is our original function, then refracted function, then label everything. Label x, y, and then origin. Of course, intercept also you need to label. Okay, let's say if just now my first part here, my f inverse, if I'm taking this part, 0 to infinity. Okay, so the procedure still same. Let the inverse equals to y, then inverse the domain and range, then here will be y plus 1. So y will become x minus 1. So that will be our f inverse. So when I drawing this part, you have to be careful because you're drawing straight line. You must have some idea on your straight line concept. So draw our reflection line, y equals to x, then we look at our function original. Gradient also 1. Okay, so this straight line is same gradient with your reflection axis. Okay, your reflection axis gradient also ms plus c, intercept at 0. Gradient is 1. Then when you look at your function, your x plus 1 intercept at 1, gradient also 1. So means both line will have parallel. So this is our hx. So when you reflect it, you can see your reflected function at here. So there these all three lines having the same gradient. So you can see the effect is all three lines they are parallel. They are parallel to each other. Okay. Keturunan mereka mesti sama. Tak boleh sengit. Mesti parallel sebab ini gradient satu, ini pun gradient satu. Automatic bila reflect graph ni mesti mereka akan symmetry. So ketiga-tiga garis ini sepatutnya akan parallel. Selari.